And I also wanted to prove a couple things he uses that maybe aren't the most important things, but it lets me talk about proof technique, which is what's important right now. So let's start with, so the first lemma we wanted to prove, I'm calling it lemma 1 for the sake of this time, is that if x and y are real, x, both positive and x is less than y, then x to the n is less than y to the n. Let's say with, sorry, I probably should have said n, again, a natural number. Okay? So if this works, I'm going to try to keep all 4 lemmas I'm going to prove and the theorem on this board. So if it looks like I'm going to erase that board, yell at me, please. So the reason I wanted to prove this is something everyone's known for a long time, but the reason I wanted to prove this is because it lets me talk about a proof technique that's really important and very useful all over math. Let's, can anybody see roughly how we probably are going to prove something like this? Induction. This is an induction. All right? And inductions are, the reason you can tell is sort of, we're trying to prove this for all the natural numbers. And maybe it's not as obvious as other inductions, but you can sort of, if you have the previous result, it's actually kind of easy to pass to the next result. So it's an induction. I'll explain what I mean by that. So we're going to do proof of lemma 1 by induction. So I actually did this proof in office hours yesterday because people were asking about like induction and just generally. I gave a more general problem on the worksheet. So yeah, I'm going to try to get through this. I'm going to try to get through the complex numbers, and we're going to spend the rest of the day on the worksheet. And just have you guys work for a while, and then I'll talk about a couple of the problems you want to talk about. But okay, so what is induction? I mean, I'm under the impression all of you have at least seen it once. But if you haven't, the idea for induction, and I always make the same joke, so I apologize to those of you who already heard it. It's like, I think of it as a domino effect. So I always tell people, think of V for Vendetta, because induction's about as cool as that domino effect, but it doesn't matter. The point is, how do domino effects work? Like if you're trying to set one up, you start laying dominoes, but you have to do 2 things. Right? First thing is you lay all the dominoes, and you make sure that if this domino falls, the next domino falls, right? And then you knock over the first domino, and then everybody falls over. Yep? That's actually how induction works, except you write it backwards. There's 3 steps to it. Usually there's the base case. This is showing that the first case works. So this is equivalent to knocking over that domino. Showing like one of the dominoes falls over, right? And then what the base case is just take the smallest case and prove it works. So in this case, the smallest case is n equals 1. So is this true if n equals 1? Yeah, I mean, if x is less than y, x is certainly less than y, right? So base case, if n equals 1, this is true, really. It's almost a tautology, really. Does that make sense? I mean, if you really want me to show it, x less than y implies x less than y. Great. So the next step, the next 2 steps in induction are the other parts of the domino effect. Domino effect, again, you want to make sure that if one domino falls, the next domino falls. So the first thing we do is we assume one domino falls. So this is called the inductive hypothesis. So you assume maybe if x is less than y, still positive, then x to the k is less than y to the k. Yeah? And that's just assuming some domino is going to fall down. So you want to make sure the next domino falls down. So then you have the inductive step. And what you do here is you just prove that x to the k plus 1 is less than y to the k plus 1. Does that make sense? I mean, this is a domino effect. That's all. I mean, if you have trouble like picturing how induction works, just think of dominoes. Otherwise, let's just finish up this step. So I'm actually going to ask you guys to help me a little because this isn't actually that hard of a proof. I just wanted to show you how roughly analysis proofs go. So I want to show x. So I want to show. Maybe I'll do it on the next one. So for the inductive step. Again, I want to show that x to the k plus 1 is less than or equal to, or less than y to the k plus 1. Okay? And so what do we have? Well, we have that x is positive and less than y, and we have that x to the k is less than y to the k. Right? So let's see if we, so with these two below, we have to show this last step. So I have a question. Do you guys have a suggestion how I should start? Multiply what by this? So multiply both sides of what, though? See, the thing is, and this is literally how you figure out analysis proofs. Like, you have two things. There's not very much you can do. You realize I want an x to the k plus 1 on the left side of some inequality. Well, I have this inequality with x to the k. It seems pretty wise to just multiply by x and see what happens. So if I so maybe I'll call this guy equation 1 and I'll call this guy equation 2. So if we multiply 2 by x, we get that x to the k plus 1 is less than y to the k times, or x times y to the k.
Which is less than y to the k plus 1.
Right, and that's what we're going to get to next. And the thing is, you really, like, this is how these inequality things usually go. You're like, oh, I have this inequality. I want to make it, well, this is great, but I want y to the k plus 1 on the right. So I have to find another inequality that somehow tells me that this is less than y to the k plus 1. Yeah?
That went up there because you already know that that's y to the k is more than x to the k. So you know that y to the k plus 1 be more than x times y.
Sure, so you could try to do that, and that'd be fine. You could use equation 1 to say x is just less than y, so this must be less than that. That'd be fine. But if you want to make it concrete, the way I would say is now using equation 1, multiply by, I don't know, do I want equation 1? Yeah, I do. I want to multiply by y to the k, yeah. Thank you. But the point is, look, now we have this inequality that says x to y to the k is less than y to the k plus 1. And I mean, and you think I'm kidding, but like, even analysis, like proofs I do in my thesis, go roughly like this, in the sense that I'm like, I want to get this bounded by this other thing. So I see, well, what can I bound this by? Okay, what can I bound this by? And I just keep doing that, and I do my best to think my way through how to get to what I want. Okay? So I mean, this is just, I mean, I realized, especially yesterday, that a lot of the proofs in this class are just intimidating. What you have to learn is, like, when Rudin did these proofs, he did the exact same thing. He sat there and like said, well, I want this to happen, what can I say, and how can I make it happen this way? He did a lot of scratch work. I promise you that was not his first effort at the proof, the one he has in the book. All right? But great, so now we have, from both of these, we have that x to the k plus 1 is less than y to the k plus 1, which is what we wanted, so by induction we're done. Agreed? But again, I wanted to show you this because, one, you should know induction. It'll come up again. I don't think there's any on the homework because the homework's, I know the homework's a bit long and a bit ridiculous. We'll talk, if you guys come to Office Hours tomorrow, we'll talk about it if you want. But we'll work on maybe making the next homework a little less, well, the next homework won't be as intense. It'll be out of chapter 2 anyway, so it won't make a difference. But cool, are we happy with this? Cool. So there's one more, so now I asked you to prove, or I said now let's prove another lemma. And so the reason I'm calling these lemmas is I'm actually going to come up with a fourth one just to make the proof of the theorem just obvious. But the point is these lemmas are just the steps he does in the proof without telling you. These are the different facts that he knows or proves somewhere and then says, I'm going to use them in the big proof to prove the big theorem. So I'm breaking it up for you. And this is actually a helpful way to study too. You're reading through a proof that just doesn't make any sense. First thing you should try to do is give an outline of what he's doing, right? These are the steps. He's proving this, he's proving this, he's proving this, and putting them together to get this. That is how you break down, especially in a book like Rudin. So I don't remember what I called lemma 2. It's either one of two things. But, right. So this was the one where I said if x is a real, x is between 0 and 1, x to the n is less than x less than 1. I mean, this inequality is obvious. So, oh, right, sorry. And I should really be careful on this one. Because it's not just for any natural number, it has to be at least 1. Or at least 2, sorry. Okay? So cool. So I'm going to ask you guys again. How do you think I should prove this? Yep. I didn't erase it on purpose. Again, it's a fact. Like the idea is just, well, okay. The idea is, oh, I already know that